I am Bishakha Dewan. Today I am presenting an important topic, mechanism of size reduction. Now, mechanism of size reduction. Mainly solids are broken in 4 different ways. 1. Compression, 2. Impact, 3. Attrition, and 4. Cutting. In generally, compression is the main mode for coarse reduction, giving off only few fines. In this method, the material is crushed between the rollers by application of pressure. Here we can see compressive size reduction mechanism, impact mechanism, attrition mechanism, and cutting mechanism. The roller mill which run on the mechanism of compression. Now we are discussing about the roller mill. Roller mills accomplished size reduction through a combination of force and design features. If the rolls rotate at the same speed, compression is the primary force used. Here, slower operating speeds do not generate heat and there is very little moisture loss. Particles produced tend to be uniform in size, that is, very little fine material is generated. For similar size particles, bulk density of material ground on a roller mill will be about 5 to 15% less than material ground by a hammer mill. Here we see a picture of a roller mill. In this roller mill, mainly a delivery device present to supply a constant and uniform amount of the material to be ground. A pair of rolls we see which mounted horizontally in a rigid frame. One roll is fixed in position and the other can be moved closer to or further from the fixed roll. The rolls counter rotate either at the same speed or one may rotate faster. Roll surface may be smooth or have various grooves or corrugations. Now we are discussing about impact. This is the breaking up of material when it is hit by an object moving at high speed. The product is coarse to fine. An example of this impact mechanism is hammer mill. Hammer mill is the most widely used grinding mill and among the oldest. Hammer mill consists of a series of hammers, usually 4 or more, hinged on a central shaft and enclosed within a rigid metal case. It produces size reduction by impact mechanism. The materials to be milled are struck by these rectangular pieces of hardened steel, which is called ganged hammer, and which rotates at high speed inside the chamber. These radically swing hammers from the rotating central shaft move at a high angular velocity, causing brittle fracture of the feed material. Hammer mills crush materials into 2 stages: size reduction, which occurs by dynamic impact, and sizing, which occurs by attrition and shear in the second zone, where small clearance exists between the hammer and the screen bar, producing a particle range of 15 to 50 micrometer. Here we see a picture of hammer mill. Now attrition. In attrition, the material is subjected to pressure as in compression, but the surfaces are moving relative to each other, resulting in shear forces which break the particles. An example of attrition mechanism component or instrument is disc attrition mills. Disc attrition mills runs in the attrition mechanism. These types of mills make use of shear forces for size reduction and also attrition mechanism. Mainly is the fine size range of particles it is used. There are several basic designs of attrition mills. The single disc mill has a high speed rotating grooved disc leaving a narrow gap with its fixed casing. Here we see a picture of disc attrition mill. Here we see a single disc. Now cutting. The material is cut by means of a sharp blade or blades. A rotary knife cutter runs in cutting mechanism. Now we discuss about rotary knife cutter. Rotary knife cutter is suitable to shear and crush the lumber and elastic materials such as rubber and plastic. Rotary knife cutter features a rotor assembly equipped with 5 full-length knives that cut material against 4 stationary bed knives until particles become small enough to pass through apertures in a large semi-cylindrical screen. Rotary knife cutter offers greater shear and less impact, yielding particles having exceptionally clean cuts in tightly controlled size range with little or no fines or dust. Here we see a rotary knife cutter. Here we see rotor in what position and rotary is here, and also present a fixed is here left side and also right side. We also see a screen. Now thanks to all. This is all of my presentation.